Module 6, Engine Systems, Operation, Diagnosis, and Repair. Module Overview. The engine is the heart of every automobile. It is the power source that transforms chemical energy fuel into mechanical energy motion through combustion and a series of mechanical processes. Without a properly functioning engine, no automobile can operate effectively. Module 6 is one of the most critical sections of automobile mechanics, as it equips you with the in-depth knowledge, technical understanding, and hands-on expertise needed to diagnose, repair, and optimize different types of engines. This module is designed to cover theory, mechanics, and practical approaches of engine systems, extending beyond surface knowledge into complete mastery. 1. Understanding engines and their types. Engines come in various forms depending on design, fuel type, and application. A mechanic must know the classification thoroughly. By fuel type, petrol, gasoline engines, spark ignition, SI, uses a spark plug to ignite fuel-air mixture. Diesel engines, compression ignition, CI, relies on high compression to ignite fuel. Hybrid engines, combination of internal combustion with electric motors. Alternative fuel engines, powered by CNG, LPG, hydrogen, or biofuels. By configuration inline, I4, I6, V-type, V6, V8, V12, boxer flat engines rotary, Wankel engine. By cooling system, air-cooled engines, liquid-cooled engines. Each configuration has its strengths, weaknesses, and use cases. For example, inline-4 engines are compact and fuel-efficient, while V8 engines provide high power for heavy vehicles and sports cars. 2. Engine components and their functions. An automobile mechanic must fully understand each engine part, how they work, and how they interact. Cylinder block houses the cylinders, pistons, and crankshaft. Cylinder head contains valves, spark plugs, and sometimes camshafts. Piston moves up and down inside the cylinder, compressing the fuel-air mixture and transmitting force. Connecting rod connects piston to crankshaft. Crankshaft converts reciprocating piston motion into rotational motion. Camshaft controls opening and closing of intake and exhaust valves. Valves. Intake valves admit fuel-air mixture. Exhaust valves release burnt gases. Flywheel stores rotational energy and smooths engine operation. Timing system ensures synchronization of pistons, valves, and crankshaft. Lubrication and oil pump reduces friction and wear. Cooling system maintains optimal temperature. Each part's condition and maintenance is critical for engine health. Even a small malfunction, like valve misalignment or worn piston rings, can drastically reduce performance. 3. The four-stroke cycle, Otto cycle. The four-stroke cycle is the foundation of internal combustion engines. Intake stroke, piston moves down, intake valve opens, fuel-air mixture enters. Compression stroke, piston moves up, mixture is compressed. Power stroke, spark plug ignites mixture, combustion force pushes piston down. Exhaust stroke, exhaust valve opens, piston pushes out burnt gases. A mechanic must not only understand the theory, but also observe engine timing, compression ratios, and valve clearances to ensure optimal performance. 4. Common engine problems and diagnosis. Engines are prone to wear, tear, and faults due to heavy use. This section teaches mechanics to diagnose symptoms and trace causes. Overheating, caused by coolant leaks, broken fan belts, radiator blockages. Knocking, pinging, poor fuel quality, wrong ignition timing, or carbon deposits. Loss of power, worn piston rings, clogged fuel injectors, dirty air filters. Hard starting, faulty spark plugs, weak battery, poor compression. Excessive oil consumption, worn valve seals, piston ring damage, black/blue/white smoke, fuel system imbalance, oil burning, coolant leak. Diagnosis methods, visual inspection, leaks, loose wires, oil level. Compression test, vacuum gauge test, use of OBD2 scanner for modern vehicles. 5. Engine maintenance practices. Preventive care is essential for long-lasting engines. Regular oil change, every 5,000 to 10,000 kilometers depending on oil type. Spark plug replacement, at recommended intervals. Air and fuel filter maintenance, clean or replace filters periodically. Cooling system, flush, prevents overheating. Valve, adjustment, ensures proper clearance. Timing, belt chain inspection, replacement before failure to avoid catastrophic damage. Battery and electrical system checks, ensures proper ignition. 6. Practical skills for mechanics. This module emphasizes hands-on learning, engine disassembly and reassembly, measuring piston ring gaps, crankshaft journals, and valve clearances, using torque wrenches to tighten bolts to specifications, testing fuel injection and carburation systems, aligning camshaft and crankshaft during timing belt replacement, using diagnostic tools, multimeter, compression tester, OBD2 scanner. 7. Emerging trends in engine technology. Modern automobiles demand updated knowledge. Turbocharging and supercharging enhances power output. Direct fuel injection improves efficiency. Variable valve timing, VVT, optimizes performance at different speeds. Hybrid engines require both mechanical and electrical expertise. Electric vehicle, EV, integration. While EVs use no traditional engines, mechanics must understand hybrid systems and transition technologies.